Hi everybody! So in today's video we are going to be learning about Unit 2, Lesson 4, which is going to be about two new rules for finding the derivative of functions. Today we're going to be learning how to apply the product rule for derivatives and the quotient rule for derivatives. So what I'd like to start by doing is just teaching you the two rules. So we're going to write them down almost like a formula, and then we'll do several example problems so that we can see how these rules work when we actually go to do a problem. So the first rule is going to tell us how to find the derivative of the product of two functions. So I'm going to start by saying kind of what we're doing. So we're going to find the derivative. So d over dx means find the derivative of the product of two functions, which means we're going to have a function that I'm going to call f of x times another function which I will call g of x. So if you ever see a function or an equation where it says you have two functions multiplied together, then when you find the derivative, you need to follow this rule. The rule is you take the derivative of the first function, so f prime of x, and you leave the second function alone. So it's just g of x. So take the derivative of the first one, leave the second one alone. Then you put a plus sign, and then you take the derivative of the second function, so g prime of x, and you leave the first one alone, so f of x. Now you'll notice these are being multiplied together. So it's f prime of x times g of x and then plus g prime of x times f of x. But when I say this in my head so that I can remember the rule, I usually say it as it's the derivative of the first times the second plus the derivative of the second times the first. Now, similarly, we have a special rule for what we do when we need to find the derivative of the quotient of two functions. Now, as a reminder, the word quotient means division. So we're going to be looking at the division of two functions here. So I'm going to write this as f of x divided by g of x. So the rule is that if you ever see a problem that has a fraction like that, a rational function, the division of two functions, then to take the derivative, here's what you do. First, you copy the bottom function. So you copy the bottom, and then you take the derivative of the top. Then you subtract, and then you copy the top, and you take the derivative of the bottom. And finally, you put the bottom function back on the bottom and you square it. Now, this looks very complicated, and I think it definitely could be very complicated, but what I'm going to do right now is teach you kind of a song that will allow you to remember this formula without struggling with it. So I'm going to call the bottom function here low, just for the sake of saying something shorter than bottom function, and I'm going to call the top function here high. If I were to write out this formula kind of using words, it would say low, and then derivative, so I'm going to use d for derivative, of the top, so high, minus the top, which is high, times the derivative of the bottom, which is low, and then low squared on the bottom. The song goes like this. It's to the tune of like Old MacDonald Had a Farm. So it goes low d high minus high d low, and low squared goes down below. And all that is a short little song that helps you remember the order and kind of the operations that you need to do. So low means copy the low, d high, take the derivative of the top, minus high means copy the top, d low, take the derivative of the bottom, and low squared goes down below. One more time, the song is low d high minus high d low, and lo squared goes down below. All right, you're going to get really sick of me singing that song in this video, but I promise you that it actually does help you remember what you're supposed to do. So I just want to make sure that you know I'm not crazy, at least not for that reason. It really is a helpful memorizing tool. So let's talk about problem 1 here. The first thing we need to notice in problem 1 is that this is the product of two functions. And the reason it's the product of two functions is that we have the function x squared plus 1, and then we are multiplying by the function x cubed plus 3. So to take the derivative here, we're going to need to use product rule. So f prime of x is equal to, now product rule says that we copy the first function, so I'm just going to literally copy it and not change anything, and then take the derivative of the second function, so 3x squared would be that derivative, plus, and then copy the second function, so don't change anything, x cubed plus 3, and then take the derivative of the first function, which is 2x. So the way that I think about this is just if you've got these two pieces, each one gets to take a turn having the derivative, and then the other one's like the original. So keep the original, take the derivative, keep the original, take the derivative, and just switch which one you do the derivative of each time. Now, it is also okay for you to reverse the order. What you'll notice is I actually did this example in the reverse order that I wrote the formula here. So in the formula, I took the derivative of the first one first, and in this example, I took the derivative of the second one first. And that's okay. Because this is a plus sign, we can do this in whatever order we want, as long as each time we add a new piece to this product, it only has one of the functions having the derivative and the other one is staying alone. Now with quotient rule, the order matters because in quotient rule, this is a minus. And when there's a minus, you need to make sure that whatever is first is always first, which is why I think the song is really helpful here. So for the next problem where we've got quotient rule, here's the top, which I'm going to call high, and here's the bottom, which I'm going to call low. When I take the derivative here, so g prime of x equals, and I'm going to make a fraction right away because I know my answer is going to have a fraction. So the song goes low, which means x cubed plus 1, just copy it, d high, so take the derivative of the top, which is 2x, minus high, which is x squared minus 1, copy the top, take the derivative of the bottom, 3x squared, and then low squared goes down below. So you're going to copy that bottom function, x cubed plus 1, and just square it. Now the song here would be low d high minus high d low, and low squared goes down below. Now I'm not going to lie to you. On the AP test, they're never going to leave the answer like this. They're always going to simplify it. So what they would do here is that if this was like a multiple choice question, is that they would expect you to start by distributing, and then they would expect you to combine the like terms. Now, I'm going to walk you through this just so that you can see how this would work out. When I distribute the 2x, I would get 2x to the fourth plus 2x. And then when I distribute the 3x squared, I would have minus 3x to the fourth. And then here's where it gets tricky, minus negative 3x squared. So when I distribute, I get 3x squared, and there's another minus. Two minuses make a plus, so plus 3x squared. That is the part that is wrong most often, is that students forget that this minus applies to the second term here as well. So it's minus a minus. And the denominator, I'm not going to multiply it out. I would never, ever multiply out x cubed plus 1 times another x cubed plus 1. It's never going to simplify, so just leave it kind of with the squared here. Then I would combine like terms. So you're going to notice that the 2x to the fourth and the minus 3x to the fourth are like terms here, which means my simplified answer would just be negative 1 x to the fourth, and then I can drop down the other terms and not change them. So plus 3x squared plus 2x. And that would be kind of the final answer. That is probably what the AP test would say. In a similar way, in this first example, you could distribute the 3x squared, distribute the 2x, and then simplify by combining like terms. For problem number 3 here, and I'm not going to simplify any of these problems because I just want to focus on the product and quotient rule, but just I wanted to show you one example where you could see the simplifying happen. For problem number 3, I know that this is the product of two functions because I have a multiplication between two sets of parentheses. So I'm going to use my product rule here. And the product rule says everybody gets to take a turn being the derivative. So copy the first, derivative of the second. I think to take the derivative here, it is easier to think about this as 3 plus x to the 1/2. So the derivative of the number 3 is just 0, and the derivative of x to the 1/2 power would be 1/2 x to the negative 1/2 power, plus copy the second, so don't change anything, 3 plus the square root of x, derivative of the first, and the derivative of 1 is 0, and the derivative of x squared would just be 2x. So that's how you use product rule. For problem number 4, we're doing quotient rule because we have the quotient of two functions. So here's my low and here's my high. Again, I'm going to sing you the song. I know it sounds silly, but it really will help you remember if you sing it to yourself. So the problem is going to go low D high minus high D low, and low squared goes down below. So low would be x to the 4th plus 5. D high would be 3x squared plus 4x minus high, so copy the top, so x cubed plus 2x squared plus 1. D low, so derivative of the bottom would be 4x to the 3rd power. And low squared goes down below, so that would be x to the 4th plus 5 squared. All right, that is what you need to know about product and quotient rule. What I'd like to do now is an example where we're given a table. You'll notice that in each set of notes, we try to do an example where we're given a table and need to apply these rules. And the reason we try to do that is that this is a very typical kind of FRQ or multiple choice question on the AP test because it allows us to assess the rules without necessarily knowing like other rules combined with them. All right, so in this table, we have x values, f of x values, f prime, g, and g prime. And we're asked to find h prime of 2 if h of x is f divided by g. Now, we're going to do this in 2 steps. Step number 1 is we're going to actually find the derivative without plugging in the number 2. In order to find the derivative this time, I'm going to need to use quotient rule. And the reason is because this is the quotient of two functions, f and g. So quotient rule says low d high, so g of x, leave it alone, d high, which is f prime of x, minus high, which in this case is f of x, d low, so that would be g prime of x, and low squared, which means g of x squared, goes down below. Now what we're going to do is plug in the number 2. So if we substitute the number 2 in, we're going to have h prime of 2 is equal to, first we're going to do g of 2. So g of 2 would be 2 times f prime of 2 would be 1/2, minus f of 2 would be 1, and g prime of 2 would be 1, and g of 2 would be 2. Which means 2 times 1/2 is 1, minus 1 divided by 4, which just gives me 0 as my final answer. Now for problem number 6, we're going to do it very similarly, only this time we're going to be using product rule because h of x is equal to f of x times g of x this time. So product rule says everybody gets to take a turn being a derivative. So copy the first, and then the derivative of the second one, plus copy the second one, and then take the derivative of the first one. After we kind of have the formula written out, then we're going to plug in the number 2. So h prime of 2 would be equal to, let's see, f of 2 is 1 times g prime of 2 is 1, plus g of 2 is 2 times f prime of 2 is 1/2, which means we get 1 plus 1, which is 2. Now, for example 7 here, we're going to kind of look at a little bit of a different situation. At first glance, it might seem like this is pretty straightforward, but what we need to remember is that if we have this g of x here on the bottom, that actually means g of x times g of x, so g of x squared. So what we're going to have to do here is use chain rule, because another way to write this is g of x squared, where g of x is on the inside. And that tells me we're going to need to use chain rule because we have an inside function and an outside function. Now, what I'd like to do here is actually start by rewriting this problem in a slightly different way. So I'm not taking the derivative yet, I'm just rewriting. I'm going to rewrite this as 3 times g of x to the negative 2 power, because I think it's going to make it easier to do this derivative if we don't have to do quotient rule, which is a fraction, and chain rule at the same time. So rewriting this with the negative power is going to make my life a little bit easier. Now I'm going to take the derivative. So h prime of x would be equal to, I'm going to start with the outside. So the derivative of something to the negative 2 power means I would have negative 6. And then if I subtract 1, it would be the negative 3 power, and I would leave the g of x alone, times the derivative of the inside, which would be g prime of x. Now I can plug in my number. So step 3 here would be to actually plug in the number 2. Which means I would have negative 6 times, let's see, g of 2 is 2, to the negative 3 power, times g prime of 2 is 1. If I were to simplify this, I would have negative 6 divided by 2 to the 3rd power. I just moved that back to the bottom, which means negative 6 divided by 8, which simplifies to negative 3 over 4, which would be my final answer. Now, the last example that we're going to do in this video is kind of reviewing and going back to what the meaning of the derivative really is. So I want to keep coming back to what we're actually doing when we find a derivative, because sometimes we can get so bogged down in the rules, we forget what we're actually doing. So it says, suppose h of x is equal to f of 1/3 of x times g of x. Write the equation of the tangent line. So write the equation of the line that is tangent to the graph at x equals 3. So going back to what the derivative means, if we want to write the equation of a tangent line, we're going to need a point and we're going to need a slope. And after we have our point and our slope, we will be able to write the tangent line equation. What we need to remember is that the derivative is how we find the slope of a tangent line. So when we get to this step right here where we're finding slope, we're going to need to take the derivative of this function, which is going to mean using rules like, in this case, product rule and chain rule. Let's start with the point though. So the point is going to be an x and a y. It tells me that the x is 3. So to get the y, I'm just going to plug the number 3 into h of x, which means I'm going to have f of 1/3 times 3 times g of 3. Now 1/3 times 3 is just 1, so I really am going to do f of 1 times g of 3. And if I go to my table, f of 1 is 2 and g of 3 is 3, which means my answer is 6. So I've got my point. The next step would be to find the slope. In order to find the slope, I need to start by taking the derivative. So I'm going to start by finding the derivative of h, which means because it's product rule here, I'm going to copy the first, take the derivative of the second, plus copy the second, and then take the derivative of the first. So I would have f prime of 1/3 x. And here's where it gets tricky. This 1/3 x is the inside function. So then I would need to multiply by the derivative of the inside, which is 1/3. And that's chain rule. So I did the derivative of the outside times the derivative of the inside. All right, now I'm going to actually plug in my number. So you'll notice I did not plug in the number 3 before. I'm just going to plug it in now. And what that means is I'm going to do f of 1/3 times 3 is just 1. So f of 1 is 2. G prime of 3 is 1. G of 3 is 3. F prime of 1/3 times 3 is 1. So f prime of 1 is -1 and times 1/3, which means I get 2 and then -1 because 3 times 1 times 1/3 is just 1, which means my final answer here is 1. Therefore, my tangent line equation, which puts all of this together, would be y minus 6 equals m, which is 1, times x minus 3. All right, that's it for today. Thank you guys so much for watching, and I will see you for some practice.